Okay, so let's look at number 19. Right now the charge per ticket is $4, and at that price they can fill a theater of 400 people. So the manager estimates that the ticket sales will decrease by 50 people, so you're going to lose 50 people every time you increase the price by $1. So the key to this question is figuring out how many times you have to increase the price. So X is going to equal to the number of $1 increases in price. So right now the cost is $4 and 400 people attend. So at $4, every time I increase the price by $1, so X again is the number of increases, I am going to lose 50 people. So if I increase it by $1, the new price will be $5, but I'm going to lose 50 people, so only 350 people will attend. So this is a question where we're going to have to kind of balance out losing people versus higher ticket price for those that stay. So what I'm going to do in this question now is I'm going to apply the distributive property. So I'm going to apply the distributive property here and here, and here and here, and then I'm going to group my like terms. So in the first set here I have 4 times 400 is 1600. 4 times negative 50 is negative 200x. 1x times 400 is 400x. And 1x times negative 50x is negative 50x squared. So I just have to combine my like terms in the middle. I have 1600 plus 200x minus 50x squared. And I'll just rewrite that so that my x squared term is first. So I'm going to take this and I am going to complete the square because again I want to know the maximum revenue and the ticket price to charge. Okay, so to complete the square for this, I'm going to factor out the negative 50 from my x terms and only from my x terms. So I factor it, so negative 50 divided by negative 50 is x squared. 200 divided by negative 50 is negative 4x, and I'll leave myself a little bit of room. Now inside the brackets, I want to determine what I'm going to add. So I'm going to take negative 4, and I'm going to divide it by 2 to get negative 2. And then I'm going to square that to get 4. So inside the brackets I'm going to add and subtract 4. So now I want to focus on my perfect square trinomial. So I have negative 50 x squared minus 4x plus 4, and I want to close the brackets there. Now outside the brackets it would appear I would add a negative 4, but really I have to remember it was negative 50 times negative 4. So really what goes outside the brackets is 200. And to that, I'm going to combine that with the 1600, so plus 1600. So now I have a perfect square trinomial, which I will factor. So the square root of x squared is x. Half of negative 4 is negative 2, all squared. And then I combine my like terms. So there I've completed the square, and I just need to list my vertex. So my vertex in this case is 2 and 1800. This here, of course, would be the maximum revenue. And this x value here would be the number of increases in price. So this basically says that I'm going to increase the price 2 times to get a maximum revenue of 1800. So going back to our first price of the ticket was $4, and we're going to increase it by $1 each time. So $4 plus $2 means that my new price is going to be $6. So I'm going to set the tickets for $6 to get a maximum revenue, $1,800.
Made with Doodlecast Pro.